Well, welcome back to Workshop Friend and the cooler weather now that the autumn's coming. So I'm working today on a problem I've had with my Adcock and Shipley mill right from the beginning, and that is one of the hand wheels. So the machine comes with these nice dials and they are lockable. So there's this knurled ring here so you can reset them at any position. And I find these features very useful. I don't have DRO, so that's actually quite important for me. So the vertical and the cross feed are fine, but the longitudinal isn't. Let me show you what the problem is. This is the thrust bearing. So there's a stack of components, and the dial was on here. There were a couple of spacers in there as well. And then there was the lock nut. What the lock nut was doing was actually locking up across the whole length of the lead screw. Let me zoom out so you can see that. There's a threaded nut on the end here which is lockable, and a thrust bearing here, and there's a thrust bearing in there. So when you undid that nut, which is intended just to lock the dial, effectively you lost the location of the lead screw, and it would then slide back this way. Clearly that wasn't right. As long as I've had the machine, I've just left this locked up like that and it works fine. It's okay. But of course you can't slacken off the dial and reset it. I wanted to sort this problem out, so I've had a look at it and I think I figured out what the issue is. Well, these are the components I took off the machine, and basically it came with all these in the stack. Obviously is the dial, and here's the nut, so those two are self-explanatory. Then there is this shouldered ring with internal step there, this which has a keyway in it, and a spacer. That spacer looks like it could be original. That looks like it was added later. So having sort of studied it and the geometry of the shaft, I came up with a drawing, and I think that explains actually what is supposed to happen. So here you have the shaft. That's basically a 1-inch diameter shaft all the way through to here with a 1-inch thread, and then it steps down to 7/8 and something a bit smaller on the end here. So the handle goes on here. That's totally separate from all of this. Here you've got the threaded ring, here you've got the dial, and here's the thrust bearing in brown, and then we've got this ring here is in lime green, and we've got this piece here and a spacer. So we need all these components, but that can be put on one side. And what's missing is this red bit, and in the shaft there is a groove, and it seems to me that that's a cotter. So basically there's a ring, a split ring that slots into the groove. This comes over the top, holds it in position. So I've taken some dimensions and produced a little drawing for this little split ring we need to make. 1 1/4 inch diameter stock with 0.74 hole. The width is critical, 0.254. I checked that with slip gauges. So the slot is actually slightly tapered, so that's kind of the size at the bottom of the groove. Put some chamfers on there, and then we need to split it. So fortunately I have some 1 1/4 inch diameter stock. This is mild steel, which is more than adequate I think for this job. So it's just a simple job. So we'll go over to the lathe and start machining this. Just picking up the edge of the parting tool on the face here, and then I've set my clock up on the saddle down here, and what we'll do is we'll just index across the required 254 thou. It'll be interesting to see how accurate this comes out. Point 1, point 2, point 2, 5, 4. I'm going to lock the saddle. So it's an opportunity to use my new rear tool post holder with the parting tool. We'll see how this goes. We'll slow down a bit. I'm pausing the parting operation to chamfer the rear side of the ring. .254, spot on. Okay, the ring has come out really nicely and it's a wonderful fit in the slot, just what I was hoping for. Now, the next operation is to split it, and I'm going to use one of my slitting saws. Up till now, I've always done that in the lathe with this little arbor I made up, and so I used that long before I had a milling machine. But I mean that's cumbersome, and I really would like to start to do this operation in the mill. So to do that, I'm going to have to make a slitting saw holder, and I've come up with a design. I'm going to hold it in my ER32 collet. This will be a 20 millimeter diameter shank, and then I've got my range of, these are 1-inch bore slitting saws, and I'm going to hold those on a bush, which will be a nice fit in the body, so that will provide the radial location. I'm going to use a 5/16 UNF bolt, countersunk, so that I can come up close to the end of the work here. For example, if I'm working over a vise, I can get quite low down, so that's the idea there. I've paid a little bit of attention to the details here, and I've made this as thin as I can. That's only 1/10 of an inch, 100 thou, so what's that, 2.5 millimeters. And then I'm going to waste the rim here, you can see in this detail, I think down here, so that it grips right on the perimeter, so as far out as possible, and also that will avoid any danger of picking up the corner here. So it's a fairly straightforward operation. I've got some EN8 steel, the right diameter, that's 1.5 inch. So we'll go over to the lathe and start machining this body. The total length is 3 5/8, so we'll go over something like 3 1/4, around about there. If I clock up that portion, then the rest can run out and it will be trued up later with other machining operations. Hope that makes sense. Okay, we're ready to part off. I just set the vernier depth gauge to 3 5/8, 3.625. So we'll just touch off on there and then just come out a bit more for cleaning up. Okay, for the undercut in the flange, I've ground up this little grooving tool, so it's got the required clearances, including the extra clearance on the outer radius, and it's the right width, so we should just be able to plunge that in 10 thou and that'll give us the groove that we need. Unfortunately, I forgot to video the grooving operation, so you just have to take that as read. In the meantime, here I am opening up, ready for the bolt hole. If you want to see the construction of my rear tool post, which I found immensely useful for parting off, then do see this link here. So as it turns out, I ended up making 2 of these end caps. The first one was fine up to the undercut here, and the issue was that I got this diameter correct, but then in forming this undercut I slightly touched the diameter. Maybe the tool slightly moved inwards and reduced the diameter there, so it ended up with this slightly slack. I think you can hear that, if not see it. So I made a second one. This time I was extra careful with the undercut and I was able to get a nice fit. Before putting the undercut in, I tried mounting the saw, and you could tell that it was indeed sitting on the internal radius, so it definitely needs the undercut to get a nice seat up against that shoulder. Since I renovated this collet chuck, I found it immensely useful, and you can find a link to those videos here. Now, in case you're wondering, the run out on the yoke, which operates the collet chuck, doesn't affect its concentricity. That seems to be a feature of the chuck which I wasn't able to eliminate. It's due to the clearance of the outer ring over the main assembly. So here I'm adding the 0.010 of an inch or 0.25mm clearance as per the drawing. Finally, I'm cutting the 5/16 UNF thread for the bolt. Now that the thread is cutting square, I can remove the tailstock support and finish off by hand. I've removed the bush to my Myford lathe and I'm just machining out the counterbore for the socket head cap screw. Okay, so one last operation, that is just to skim up the outside diameter. So at last we've got our slitting saw Arbour ready. I hope that this will not be just used for slitting saws, but I hope that I can use other small milling cutters on this as well. Got to get the direction right so that as the torque comes on, it tends to tighten the bolt. So that way, yep. There we are. Let's give it a try. Using a feeler gauge here on the outer diameter, and then I'll traverse upwards to reach the center line and then make the cut. The eccentricity you see here is not due to the arbor, it's the fact that the hole is not central in the slitting saw itself. Very frustrating. Well, just in case you need reminding of what the original job was, this split collar fits over the shaft here, so it's the red, and it fits over the shaft in this groove, and this is the housing which holds the split collar in position, and that's shown in green. And the reason we wanted to get a nice fit was because the preload comes from the other side. So this basically, the lead screw is put into tension, tightening up on this thrust race here, and that puts load on this split ring against this side of the groove. Now when you tighten up the the indexing ring. So this is the indexing ring here. So when you tighten this up, it puts load on the other side of the ring and potentially changes the preload on the bearings. So we'll put this together and we'll see if this has worked. Good. That's in. Okay, we'll just put some preload on the bearings now, so we'll tighten up the other side. I'm not sure really if it's preload so much as just eliminating the backlash. So this split nut has a screw in the middle, so that as you tighten the screw up it locks on the thread. So we just tighten this up. Okay, maybe we don't need that spacer. No, we don't. When I produced the drawing, I thought the spacer was borderline. Okay, we've got a bit more backlash to remove, and that has to be done from the other end, but in principle this works. Okay, let's just sort the backlash out and then we'll come back and have another look at it. Lock that up and then see if we've got rid of the backlash. Well, I fiddled around with the lead screw nut on the other end to eliminate the backlash. So we've got a little bit of preload in fact on those two bearings, one at this end and one on the other. I wound the table across to the extent here so you can see what's going on, and the first thing I note is we have around about 0.3 of a millimetre of backlash, so it's about 12 thou, and that's all in the, must be all in the lead screw nut. I think that's okay, that's not too bad. But the whole point of this exercise was to restore the function here, being able to set the dial. So you can see now that I can do that, I can set that to 0, and I can see exactly where I'm going. So it looks like this split collet has been successful, and it doesn't seem to affect the load on the bearings. There we are, great, this would be very useful. Well, this has been an unusual video. In the process of solving this minor problem, I ended up making the slitting saw, but I'm sure that will be very useful for future projects. Thanks for joining me. I do hope you'll join me for the next video to come out soon.